Now, in those problems I was working before, I kept it to ones that did not have remainders. And that's how we usually introduce division, is things that would divide evenly. But then we do want to get to things that would not divide evenly. So things that would have what we call remainders. This problem is going to have a remainder. We're not going to deal with writing it as a decimal, as a fraction. So I don't want you just to type something in a calculator. We're just going to leave it as a remainder. So we're going to have something with a remainder of something kind of as our answer. So here we've got a problem. There are 8 students and Charlie brought 30 suckers. How many suckers does each student get if they have to have the same number? So he can't give somebody an extra sucker just because he likes them more. He has to be completely fair. So I want you to think about this. You can think about drawing a picture. You can think about maybe listing out multiples. You could use your calculator as a tool if you wanted to, but my final answer cannot have a decimal. So go ahead, hit pause, and see if you can figure this one out. All right, let's see how you did. I'm going to work it out a couple different ways. So let's say that I know that there are 8 students. So if I gave everybody 1 sucker, that would be 8. If I give everybody 2 suckers, that would be 16. 3 suckers would be 24, and 4 suckers would be 32. Well, I don't have 32 suckers. So the most I could give away was 24. So that was 8 times 3. So then everyone would get 3 suckers each. And since I had 30 and I could only give away 24, I would have 6 remaining. So 3 suckers each with 6 remaining. You also, would be a little bit more painstaking, I chose a big number, can think about drawing 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And putting them in groups of 8. So I could have a group of 8 here, a group of 8 here, and a group of 8 here. So we can see there's 1, 2, 3 groups, so that's 3 suckers, and we can also see the 6 leftover suckers if we wanted to draw a picture. You also could have typed this in your calculator and divided 30 divided by 8, and that would have gotten you a whole number of 3, so you get like 3.75. So just that whole number, that would give you the 3 suckers each. You have to do a little bit of work to get that 6 left over. We asked for that remaining. But it's a perfectly fine answer, just to kind of have to write out in words what's going here, the 3 with the remainder 6. Some people might be used to writing 3 remainder 6 or something like some notation like that, and that would be fine as well. But kind of going off of something that kind of shows all that same information. Now, I already alluded to this dividing by 0. That's something that does usually come up. And that's why I've got this definition up here. When we divide by 0, some weird things happen. And people get confused on when an answer is 0, when an answer is undefined. So I just kind of want to go ahead and go over it. So if I'm dividing with 0, there are 3 different possibilities. Thinking about here, I could have that 0 as my divisor, as my dividend, or as both. So I've got it as the divisor, I'm going to have it as the dividend, and I'm going to have it as both. And you could really have any number in the place of that 5. I'm just going to choose a number to make it like realistic here. Again, I know I'm flipping back and forth, but going back to this definition that we have up here, we've got A divided by B equals C, and I'm going to rewrite this as a multiplication problem. So I'm going to set all these guys equal to C and see what happens. So when I rewrite them, that dividend is going to be my answer, just like we saw with the missing factor here, that dividend became the answer. So when I rewrite this guy, I get 0 times C equals 5. So 0 times some number has to equal 5. That can never happen. That's impossible. 0 times any number is going to give you 0. So this literally can't happen. So this is the undefined answer. We might be used to seeing it like this with 0 in the denominator. You can even check in your calculator. It's going to tell you there's an error. That's because we can't have that happen. There's no number in the world that I could plug in for C and get out an answer of 5. So it just doesn't work. Let's see, going this other way. Again, remember that dividend is going to be my answer there. So 5 times C equals 0. So 5 times some number equals 0. This is true when C is 0. 5 times, or plugging in here, 5 times 0, when C is 0, 5 times 0 does equal 0. So this would give me the answer of 0. When there's a 0 in your numerator, if we're thinking about fractions, I know we're not to fractions yet, the answer is 0. Again, you can check this in your calculator. You can see if you typed in 0 divided by 5, you would get out the answer of 0. The reason that gives you 0 and 5 divided by 0 doesn't give you 0 is this idea with the multiplication. That's the reason they're not the same answer. So then this last one, what if they're both 0? What happens? Seems like it could be either one. Again, we're going to 0 times C equals 0. Change it to its multiplication sentence. Well, I could put any number in for C. C, we could each think of a different number. C could be 5, it could be 27, it could be 3,000. It doesn't matter. C could be any number. And if we look at our definition, it has to be a unique number. C, it only works if there's only one answer for C. This problem has infinity answers. So that means it also doesn't work. So that's the reason when you have a 0 in both the numerator and denominator, or the dividend and the divisor, however you want to think about that, then my answer is undefined. It's not 0.